Okay, question 9.1 says in the diagram JKLM is a cyclic quadrilateral and the circle has center O. Prove the theorem which states that J plus L is equals to 180 degrees. Basically, the opposite angles of a cyclic quadrilateral are supplementary, meaning they add up to 180 degrees. So in this case, we are looking at the suspects J and L. Our first step in this proof is to construct. So we want to construct radii, or just draw KO and OM. So something like this. Cool. Then you want to partition it such that we have O1 and O2. Then, as you can see from this, KOM forms an angle here at O1. We also form an angle here at O2. And depending on the way you look at it, O1 would be the angle at the center for J. So we are going to apply the theorem of the angle at the center is twice the angle at the circumference. To prove one theorem, we need to borrow the application of the other. So our first step in this case, I'm going to say let J be equal to X, and also let, then we know that O1 would be equal to 2x. This is because of angle at center is twice angle at circumference. Then from this we can also say then O2 is equals to 360 minus 2x. Remember 2x is O1, so 360 minus O1. How do I know this? This is angles around a point. We know they add up to 360 degrees. So that's that. O1 plus O2 are equal to 360. Then we can say from this that L, now this is where a few students get it mixed up. This is clearly visible that O1 is the angle at the center for J. But similarly, we could also say that for this other side, this would be our O2 would be our angle at the center. But just because the shape is a bit more awkward than the one that we are used to, we tend to overlook this law that we see here. So this is still the angle at the center for this angle over here. So at this point, we then say L2 is equals to half of O2. So L, not L2, just L. L would be equal to half of O2, which is 360 minus 2x. That would be O2 divided by 2. That will then be 180 minus x. Then we can say the reason for this is again angle at center twice angle at circumference, like that. Then if I now add J plus L, I get X plus 180 minus X. You can put yellow brackets since this is a substitution, and then we're gonna basically have 180 at the end. So we've proved that J plus L is equal to 180 degrees.